Hello students, come to the next lecture, capital F distribution. So let's see the formula of the capital F distribution. F equal to S1 square by S2 square or S2 square by S1 square. See, this formula will use when S1 square is greater than S2 square, and this formula will be used when S2 square is greater than S1 square. See, this formula will use when s1 square is greater than s2 square, and this formula will use when s2 square is greater than s1 square. So what is mean by s1 square and s2 square here? I think we see in the last lecture t distribution. So the meaning of s1 square is nothing but variance of the distribution. Yes. So what is the formula of the variance? S1 square is nothing but 1 by n1 minus 1 of summation I equal to 1 to n xi minus x bar whole square, and x2 square is nothing but 1 by n2 minus 1 of summation I equal to 1 to y of yi minus y bar whole square. So, what is the difference between a previous T distribution topic and this capital F distribution? Tell me. In the T distribution topic, we are getting only one sample. Here, in a capital F distribution, we are getting two different samples. So that's what here we are having the variance of the first sample and variance of the second sample. So to finding the variance, we having these are the formulas. And here, what does it mean by n1 and n2? N1 is nothing but the size of the first sample, and N2 is nothing but size of the second sample. Is it okay? Right. So let's go to the first question. In one sample of 8 observations from a normal population, the sum of the square of the deviation of the sample values from the sample mean is 84.4, and in another sample of 10 observations it was 102.6. Test at 5% level whether the population have the same variance. So what we have to prove here, whether the population have the same variance, that we have to prove it, right? So before proving this, we have to identify what are the values are given in the question. Yes. So then only we can solve the solution, yes or no, right? So let's identify first of all, what are the values are given in the question. In a in one sample of 8 observations from a normal population. So can I say this is nothing but the size of the first sample, because he's asking in one sample of 8 observation, and here he is asking that in another sample of 10 observation. So which is nothing but this is about the first sample, and these values about the second sample. Yes. Okay. So in one sample of 8 observations from a normal population, the sum of the square of the deviations of the sample values from the sample mean is 84.4, right? So let's write the given values from the question. Okay. So given sample size n1 equal to 8. Yes. And also given you in the question, sum of the square of the deviation is 84.4, right? So my question, how do you denote this value in terms of probability? Tell me. Sum of the square of the deviation. So can I say here, given you in the question, this value, sum is nothing but addition, summation, square, sum of the square of the deviation. Deviation is nothing but minus, can I say? So which of minus? See, in the question is telling that deviations of the sample values from the sample mean. So what is mean by x bar here? X bar is nothing but, can I say, the sample mean? Yes. So the sample values from the sample mean is, so we can denote it as here summation I equal to 1 to n xi minus x bar whole square equal to 84.4. This is the value of this. Okay, now continue the question. In another sample of 10 observations, so another sample of 10 observations is nothing but, can I say, different sample size? Yes, some other different sample. So sample size n2 equal to 10 is given in the question, right? And also given you it was 102.6. So what is the value of this 102.6? So can I say again the sum of the square of the deviation? Yes. So this is the value of the sum of the square of the deviation, 102.6. So which can be written as summation I equal to 1 to n yi minus y bar whole square equal to 102.6. So now coming to the solution. To solving this capital F distribution, we required a value of s1 square and s2 square. Is it correct or not? Yes. So in my question here, does he given the value of s1 square and s2 square in the question? No, right? So what I have to do now? I had to find a value of s1 square and I had to find a value of s2 square, right? Then I can solve the solution, right? So coming to the formula s1 square, it is equal to 1 by n1 minus 1 of summation I equal to 1 to n xi minus x bar whole square. So by substituting the values here, 1 by n1. n1 is nothing but 8. 8 minus 1 of summation x I equal to 1 to n xi minus x bar whole square value. What is given in the question? 84.4, right? So 84.4. Then the required solution of s1 square equal to 12.057. Okay, right. So similarly we'll find here the value of s2 square. It is equal to 1 by n2 minus 1 of summation I equal to 1 to n yi minus y bar whole square. Then we'll substitute the values here. So n2 value 10 minus 1 of summation of yi minus y bar whole square value. How much is given in the question? 102.6. Okay, so then by solving the solution s2 square equal to 11.4, right? So now I got a values of s1 square and s2 square. Yes. So now we'll go to the required solution. Okay, so s1 square equal to 12.057 and s2 square equal to 11.4. So what I observe here, tell me. Here we got s1 square is greater than s2 square. So s1 square is bigger than s2 square, right? So can I say, can I use the formula this one or this? Yes, we have to use this one formula, right? Because s1 square is bigger than s2 square. So therefore test statistic f equal to s1 square by s2 square. It is equal to 12.057 by 11.4. Then the solution of capital F equal to 0.057. Okay, so now this is the value of capital F value. Now we need a value of f alpha. Yes, so we need a value of f alpha. So before getting a value of f alpha, we'll observe, did he given the value of alpha in the question? Right, let's see once. See, test at 5% level of significance. So it is nothing but alpha value is given you 5%, right? So alpha equal to 5 percentage. It is nothing but 0.05. So if alpha value is 0.05, and after that we need a value of nu1 as n1 minus 1 and nu2 equal to n2 minus 1. Did you remember in the t distribution we are taking the value of t alpha with a combination of alpha and nu? Did you remember? So similarly here also I'm taking the value of f alpha with the help of nu1, nu2 and alpha. So nu1 equal to n1 minus 1. So here n1 value is 8 and n2 value is 10, right? So 8 minus 1 equal to 7 and nu2 equal to 10 minus 1, it is equal to 9. So this is the value of nu2 and this is the value of nu1, right? So then what will be the value of f alpha at 0.05? It is equal to, now let's go to the table of this capital F distribution. The table, see here, alpha 0.05. Observe here, alpha value 0.05, and in this table also alpha value 0.05. Coming to the next one, alpha value 0.01 and here alpha value 0.01. So it is nothing but the conclusion of this capital F distribution table. There are four tables we are having, and first two tables in terms of alpha 0.05 and second two tables are alpha in terms of 0.01, right? So coming to the first table of the 0.05, see, these are the column values in terms of no one. Okay, and these are the row values we are observing in terms of no two. Okay, so no one values we are observing in the column, no two values we are observing in the row, and here also no one values are column, no two values are row. So what is the observation in this first table? No one values are only till 9, and from here 10 to infinity. So that is the difference between the first table and second table in terms of 0.05. So coming to the third table and fourth table, here no one values are 1 2 3 4 5 6 7 8 9, and coming to here 10 to again infinity, right? So this is the conclusion between the first two table and second two tables. Okay, right? So in our question, no one value is 7, no two value is 9. So no one value 7 is here, no two value 9 is here. Then what is the combination of these two? 3.29. Yes, so 3.29 is a value of f alpha, 3.29. So what is the observation here? Capital F value 1.057 and f alpha value at 0.05, 3.29. So what is the conclusion here? Hence capital F is less than f alpha. So it is nothing but, can I say that the table value is bigger? The table value is bigger than this test statistic? Yes or no? Same variance, right? I think everyone is clear with this question, right? So I'm giving you one practice question to you. See, two random samples reveal the following results. Sample 1, sample 2. Sample size n1 equal to 10, n2 equal to 12. sample mean x bar equal to 15, y bar equal to 14. Sum of the square of the deviations from the mean 90 and 108. So can I say this is the value summation I equal to 1 to n xi minus x bar whole square, and can I say this is the value summation yi minus y bar whole square? Yes. See, in this question, he given you the values properly. Yes. So now what we have to do? We have to solve the solution by using last sum.